Hi guys, thanks for checking out our webinar on leveraging decentralized digital twins. I've gone ahead and uploaded the presentation to YouTube so you can review it anytime you have a chance. Okay. Hello, today I'd like to talk to you about leveraging decentralized digital twins. My name is Mark, I'm with 360 Matrix, and I think today we're going to need to stretch our imaginations a little bit and maybe let go of some preconceived notions about the way data should be stored in order to maybe gain some new perspective on the decentralized web and Web 3.0 principles that may give us even more security and freedom moving forward than we have right now. So let's get into it. A little bit of information about me. I've done a lot of project management in my past in the trade show industry, software development, IT management, network design and implementation. And recently I've been doing more spatial computing and reality capture as part of the things that we've been working on at 360 Matrix. And a lot of this is really exciting stuff, and I'd love to really show you guys what really can be done with some of the augmented reality and spatial mapping technology that's coming out today. So let's go. When we look at Vision 2050 and the challenges that we have, we're really looking to empower citizens to feel more connected to their community. We also want to create ecosystems of interoperable technology, and that will enable all kinds of investments and growth in this digital arena. We need to establish rules that kind of give guardrails to citizens and organizations as they interact with this data. And we want to incentivize entrepreneurs to come up with those creative solutions, especially with respect to the last mile transportation solutions, green energy solutions, and things of that sort. But probably one of the biggest things I want to do is empower citizens to take control of their data and their security using these decentralized blockchain technologies. So I think what we have here today with social media is a dilemma. We've recognized that these networks provide an amazing way to keep in touch and connect with other human beings, and certainly tech giants like Facebook and Google, they've certainly been able to take advantage of those network effects, and they've made a lot of profits off of our data. But we've been realizing now recently that there's a lot of negative aspects to participating in these networks. And if you look at the meme up here, it's kind of funny, but it's actually really serious, because I think Facebook is a company that maybe doesn't understand where the boundary of privacy exists. And they'll just keep pushing and pushing and pushing. And that's why, their latest round of devices, I wonder if they're toys or data collection devices. These devices are extremely powerful. They have extremely powerful artificial intelligence built into them. so they can do a lot of tracking and processing, even on the device that you don't even know may be going on. So now we need to start thinking about, well, if these devices are collecting information and processing information, where's that data being stored? Who's looking through that data later on today? Who has control over it? These are the things that we really have to think about as we go into these metaverse environments and digital twins and really start to participate in these shared experiences. You know, who's going to have control over my information and my likeness? That's really important. So I think what we've been seeing is this migration to a new class of application, Web 3.0. Right? So if you can think of social media as being mainly Web 2.0, you know, this ability to connect across these massive networks. Web 3.0 seeks to do some of the same things at scale, but we want to now add a trust layer to that interaction so that we can trust and verify virtually everything that happens. So what you get is self-sovereign identity, right? The ability for me as a citizen to take control of the information that I generate, right? My images, my photos, my videos, my likeness, my opinion. That's all my data, and why shouldn't I be able to have 100% control over that? There's no reason that we can't do that. And so yeah, that's something that we'd like to see. Interoperability is another thing. So we can design applications that work really well together. By default, by integrating really smart code that understands how to interact with other devices. I don't want to be too technical with it, but you know, interoperability is very, very important. Decentralized architecture also really desirable, and we'll be talking a little bit more about that later. But the ability to spread resources across a wide geographic area or a group of nodes, maybe centralized or decentralized in their location, but decentralized architecture is really important, especially for security, I think. So privacy and security, kind of comes built in. Excellent security, or at least the capability to implement really robust security. And all of this, or the majority of it, is powered by this underlying technology, blockchain. Right? And so if you know about the blockchain, that's great. And I think that is something that we really should start looking at as far as, you know, everything moving forward that we need to track and trace and verify. So, what is a digital twin? So, if you ask 10 people what a digital twin is, you'll probably get 10 different answers, because I think many people have a different opinion on what it is to them, especially depending on the industry that they're from. A digital twin is a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. And that's interesting, frequency and fidelity. So when we talk about operating in this digital twin environment, I really like the idea of being able to query three-dimensional data based on a voxel or a volume of space or a property address, and then get back all of this amazing information from that query. So these specialized digital twins that we're trying to build will be able to do that. Another thing about a digital twin is it should have a purpose, a very specific purpose. It should optimize probably for just a few key performance indicators. Instead of trying to recreate the world, we can stream in hundreds of data sources to a single digital twin, but then does the information just end up becoming noise? So we really have to focus on which problems are we actually trying to solve, and what processes are we actually trying to optimize here, and so how can that digital twin help with that process? If you look down at the bottom here, these are elements that we're interested in. There may be other elements that your teams are working with that you don't see here. That's okay. What I look at it as is just another layer of data that we are importing into or ingesting into this environment, right? So when you talk about a point cloud and a 3D model, this is the reality model portion of the digital twin. And we've been working really hard on figuring out how to automate the process of collecting and establishing that digital twin and creating laser scans in a robust reality capture workflow. So we'll talk about that a little later. So the other part to this is IoT sensor data. IoT stands for Internet of Things. So basically any device that can communicate using a standardized protocol to some kind of gateway, and then I can actually just record that information. So that could be anything that has that bit of communication built into it. So 2D and 360 cameras. It's pretty obvious. So any device, cell phone, robot, drone, and of course these specialized 360 cameras can be imported and localized into the digital twin. I'll show you a video of that a little later. And accurately geolocated also at the same time. And so it ends up becoming part of this data set that we can then query and process later on. So it's really powerful. Spatial map. This is really cool. So the spatial map ends up being this digital layer of information that allows you to align the digital twin with the real world and localize images or videos within that digital twin. So we'll talk a little bit more about that later. Computer vision is another really important part of it, and we will talk about that too. Time series data we're collecting from mostly IoT sensors, but we can actually federate or standardize any data and record it on a timeline and then process it later. So this is really interesting, where we can actually create these custom timelines that we can scrub through and really process data later on, right? So this digital twin is looking to monitor an environment or a process over time, possibly, and then we can go back later and analyze what we've collected. So yeah, AI and ML. So we're using a little bit of each. We're not, we don't have any engineers that are focused on this, but you would be surprised at how many projects out there that are ready to go for developers to integrate some of the latest AI and machine learning algorithms into their workflow. So that's what we've done, and been pretty successful at that so far. So if you'd like to discuss some of the methods that we're using, I'd love to do that. So, Decentralized App Architecture. So if you look at the Web 3.0 space here, you can clearly see that we have this idea of a layer 1 blockchain, and that is not what we're trying to build. We're not trying to interface with that blockchain as a default. We can design apps that can easily interface with it, but we don't need to operate there. What we're focused on is this layer 2 solution that would combine a lot of the technologies, right, that I talked about earlier. So we got smart contracts here, we got decentralized identity, right, DID, IPFS, which is a storage mechanism that we'll talk about, and spatial computing, which we are also going to talk about. So this is where we want to operate, and what we're trying to achieve is this decentralized trust layer, right? So we're taking all those transactions, we're taking all those files, and we're making sure that we can verify where those files are stored, that those files have not changed. If they are changed, they should be tracked. If there's any updates to the code, we should be able to track that. If there's any interactions, right, transfers of data back and forth, we should also be able to track that using our own blockchain, right? So private ledger that will handle all of the transactions. So then we can interface with a layer 3, and this is where you can bring in the third-party applications. These applications could easily be Web 2.0 applications, because they can interface with very familiar REST API, but the idea here is you can come along and create your own application and simply not have to worry about how everything is happening on layer 2, right? You create your simple app, you can be up and running very quickly with a decentralized app using this process. So hopefully that makes sense. And what we've done is we've started with storage and spatial computing, right? So smart contracts, decentralized identity. We haven't started there yet, but we already have our API. We're going to start with storage and spatial computing. Speaking of storage, IPFS. What is IPFS? It stands for Interplanetary File System. This is an amazing new protocol that allows us to save files basically anywhere we want to save them, and save on time, save on transfer costs, save on space. It's absolutely amazing. So if you look over on the right hand side, I have an example here. Is an image that is 7.2 megabytes. Not very large, but it's a decent 360 image. But if you look above, you'll see that there are these dots that are scattered all over the globe. And what those are nodes. So each one of those nodes has a small encrypted chunk of this file. The reason that we're doing that is, one, to make it the storage of this file decentralized. When you go to any of those nodes, you cannot recreate the file using any one of those chunks. So whoever's storing that file on that node. I don't know them. I don't need to know them. I haven't created a contract with them. I don't need to do that. The blockchain is handling all that for me. The distribution to the nodes is handling all that for me. All is part of this protocol. So the other thing that's really nice about this is if I need to serve this file back up, right? If I want to share this with another user and that user is in Asia, I don't have to pay to serve it from a content delivery network in Asia, which you have to do right now with AWS. So it's fine if I only have to pay a little bit to transfer this small 7.2 megabyte file. But what happens if I have terabytes of files that I need to transfer? That's why I think this this protocol is emerging as maybe an alternative that will allow you to scale your storage across a fabric of nodes that you don't have to worry about any hacker being able to gain access to your files by simply hacking into one person's computer. So there's a lot of technical ways in which it recreates the file, but it's always based on the content of the file. So that's what content addressable storage means. It's always verifiable. It's able to future-proof your data. How does it do that? The encryption algorithms that it uses can be upgraded. So if you have a error in the future and somehow somebody hacks SHA-256 and now we need to upgrade our encryption, we can actually do that with this file system. It's immutable. You cannot change a file without breaking the hash for that file. So as soon as the file changes, we know immediately that has happened. How many data breaches have you heard about and you don't hear about them until months later after the breaches happen? This file system basically eliminates that, right? You know the instant something goes wrong. You know the instant someone has accessed the resource, because we have to come to a consensus before we let that transaction actually happen on the network. It's incredibly powerful, and I'd love to talk more with you about it if you are interested. So decentralized computing infrastructure. So if you see what we've illustrated here is nodes that are located throughout a community. Some are at the city level, so that could be on a private network at the city with some nodes at the community level, community center. These nodes could be running on cell towers throughout the community, 5G towers. They could be inside of buildings, installed inside of a gateway. All it is it's a piece of software, or it's a stack of software, a group of software that runs and that's designed to maintain this network, this decentralized network. And so the idea is it's able to move around files way more efficiently, because every time a node captures a piece of a file, it doesn't continue to go back out to the main server and retrieve additional components of that file. What will happen is other nodes that are close by will report that they have the chunks that are needed. So it's really fascinating the way that you're able to move massive amounts of data around using this protocol. Decentralized spatial computing. So when we begin to interact with other devices on the network, we want to have full control over how our information is shared, right? So once we begin to localize against a digital twin environment or inside of a digital twin environment, you can now begin to track your location within that environment. And so there's already several companies that are doing this with wireless, right? So if you log into a wireless network and you use their free Wi-Fi, not only are they tracking the websites that you're going to, but they can also track exactly where you are in their space. And they can heat map that, and there's all kinds of amazing research going on around that. But just be aware that they can do that. And so as you share that information, just know that you're letting them know exactly where you are every second of the day, or at least as long as you're participating in that particular network. So we want to have these shared experiences. We want to use this blockchain technology that we've been talking about. We want this to be vendor and device agnostic, so we don't get locked in with our Apple or Samsung devices. All of these devices should be able to understand where they are in relation to each other and in relation to the digital twin environment, right? So we really need to be careful about how we participate. Because if we don't know what's going on behind the scenes, or at least have a good idea of what's going on, we can be tricked. And I think that's a lot of what's going on right now, is this kind of, oh shucks, we don't know how powerful this stuff could actually be, but please continue to share all of your information with us, and we'll see what we'll do with it later. I think it's we're starting to become a little more aware of the fact that they already have plans for this information. I think they need to really begin to disclose what they're going to do with our data as they collect it, as they process it, and find out exactly what we're doing, exactly what we're looking at. As we're being tracked more and more, we really have to think about these things. Reality model capture cycle. This is a process that I've been working on that will allow me to improve the reality model over time using various reality capture devices. So this could be handheld devices. We have laser scanners that you can cart around. We now know that we can attach laser scanners to robot dogs or small unmanned vehicles, UAVs. Obviously, drones now can be used to create a reality capture model. But what I've been focusing on is trying to automate the process, create a digital twin that you can continuously update over time on a schedule, and use what I call spatial control points to align all that information across all the data sets. So images, the LiDAR, scans, the point cloud data, all of that can be improved upon and realigned over time very accurately. So the reality model can be improved using several processes, but we'd like to look at using more artificial intelligence here. And so that's the idea, is like right now you have humans reviewing these steps, but hopefully in the future we can move that more and more into artificial intelligence, and we're just throwing some algorithms at this, right? in order to improve the process much more rapidly. All right, let's check out some videos here. So I have this on the upper left-hand corner here. This video is illustrating localizing images and point clouds and 3D models inside of a digital twin. Right, so the data is inside the digital twin, and what we have here is a simple viewer that is rendering the data inside of a browser, but the 360 images, those are not part of the point cloud. Those are separate. They've been aligned, right? We've localized those images. The 2D images, the drone images that are hanging in the sky, those are localized. So it's also geolocated too, very accurately. So check it out. So as you can see, we are looking up at the sky. We're able to click on an image and we're going to fly up to where that image was taken. This can be done in any environment, indoor, outdoor. We simply need to establish the spatial map, the digital twin, the reality model, and then any image that's taken from that point forward can be localized inside of that twin. Without starting over, we now can simply begin to align many, many more images taken from virtually any source inside of this environment. On the lower right here, we have a data collection session with some newer equipment that have been mobile mapping equipment that have been testing. Absolutely amazing the speed at which we're able to capture this data. But this is the entrance, Orange County Convention Center West, concourse. This is a massive point cloud, and the collection process and the amount of space that we're able to cover in just the 25 minutes that it took to collect this. 224 million points in this point cloud, and we're able to capture that in under half an hour. So, you know, with a traditional terrestrial laser scanner, you could be here for 4 hours trying to collect this much information, and the accuracy is just amazing. You can pick up so much detail here. Well, I guess that's the point, right? The technology is going to continue to evolve. It's going to continue to get better, and so now we're seeing that reality capture is really taking on a new era here. Here we go. The Interoperable Smart City. This is a network of digital twins that are connected together that will allow you to transact and pull and push data without worrying about privacy issues, without having to develop all the technology, underlying technology that's included in these digital twins. You would simply query the twin for data of any sort, and if you have permission to access that data, for instance, as a professor or a student, you could have free access to use the data for research purposes. As a third-party app developer, you may purchase some of this data to use in your application, or you may decide to use the platform to store some of your information in a decentralized manner, and pay for that service. Uh, Industry professionals can obviously push and pull data from the system as needed. Uh, so there's many elements here that can be considered and built out, and we don't have to have all of them working on day one. I think that digital twins will end up being specialized, and we just want to make sure that when we build them out, we make them compatible. The data that they collect should be compatible so that we can then exchange that data, right? As a community, the, the, the IoT sensors need to be able to talk to each other from any company, any vendor. The point cloud data shouldn't be in a format that I, as an industry professional, can't read, right? Because I don't have a special software. So we're really talking about making the data truly generic in nature. We want to make sure we can all come to a consensus on the standards and protocols that we're using. But once we get there, then we have a true smart city. So the open AR cloud. Wow, I really love this organization. I am a member, and it's an amazing group of people that have, I think, a really important mission, and that is to drive the development of open and interoperable technology and data standards for spatial computing, connect real and digital worlds, and contribute to the efforts of for ethical best practices. So, yeah, I think this is really important. We really need to figure out how to secure our data as we participate in this AR cloud or metaverse, right? People are calling it. Yeah, so consider joining. Consider joining the organization. I think you'll like what they're talking about. There's a lot of information exchange there that I think will help you in whatever you're trying to do. So GeoPose is an emerging standard under development in the Open Geospatial Consortium. So you want to check that out. You can actually look it up, and you can also on the OpenAR Cloud website and GitHub, you can actually look at the details of the protocol, the standard. You can actually look at the all the specifications that are involved here with the standard. So check it out, and I think that it will be something that you might want to integrate into what you're doing. AR cloud definition. AR cloud encompasses the creation, management, and use of persistent, dynamic, and shareable 3D machine-readable representations. So it's basically taking digital information and overlaying it on a image, on a video source, aligning your device, your camera on your device, to the digital data that is sitting behind it inside of a digital twin. That's really what we're trying to do here. So then you end up getting this magic window of alignment where you can align digital and reality, right? And so in order to do that, you really need to create this reality map, or what I call spatial map of the environment, and then your augmented reality is simply enabled after that. VR platforms. You may have been able to jump into our event hub earlier. Let me know if that worked out for you. But the idea is, yeah, we should be able to get together in these shared virtual environments, bring in our own data, bring in our own avatars, interact with each other, study complex problems in an open, transparent manner. And then once we're finished, we can just tear the entire thing down, the virtual space, and we don't really have to worry about meeting in a physical space. So it's kind of obvious that we're doing a lot of this right now, but I'd like to see more open source software like this, Event Hub, for making that happen. And yeah, I also love to see us use decentralized storage in order to feed some of these systems. So that's where we'd like to take it. Computer vision. We're so excited about what we're doing with computer vision and the progress that we've been able to make, using artificial intelligence, TensorFlow, and YOLO algorithms for object detection. This code is readily available for developers to integrate into their workflow, and we continue to do that. We can do amazing things like obviously accurate localization. So here's an image that I took offline, off of unsplash.com, right? And took that image, and without knowing anything about the image, I'm just able to run it through algorithm, and here it is. It's telling me that I've detected 11 cars in this image. Well, that's amazing. So this is out of the box functionality. If there was a person, if there was a dog, if there was a bike, it would identify those too. It can identify, I think, up to 80 different items out of the box. And then we can take it and we can retrain these algorithms on our own data sets, right? So now we can have it track a specific license plate in our fleet. We can track whether humans are in a particular area of the warehouse or a building or a site that they may or may not be allowed to have access to. We can do those things automatically. We can organize that data, and then we can report it back to the digital twin environment. We can do that all on site. We don't need the cloud to do that, right? Once we have trained the proper algorithms on our data and our environment, right, we just continue to learn more and more about that environment. And so this is going to allow us to create so many amazing solutions for our clients moving forward. And yeah, this is really exciting stuff. So if you'd like to discuss that more, just let us know. Well, there you are. That is pretty much it for the presentation. What I have here now is my website. Check that out. And yes, please get in touch with us if you'd love to continue the discussion after this. So, openercloud.org. This is an organization that I would encourage you to join. It's really important stuff that they're working on, so check it out. And so here we are. Let's check out our live decentralized digital twin that we've just created here for you. So just a second. All right, so here is one of our digital twins. It is of a local Orange County property here in Orlando. So check it out. So all of this information is being served from a decentralized data storage. So thousands of nodes around the world will be used to recreate this digital twin. So we're not uploading it to a single Amazon bucket, which is also an option, but we really want to illustrate that this can actually be done today. So this is the same one from the video, but you can see if I click here, it's going to take a bit to load because I am streaming, but here we are. So the image popped in here and it's automatically aligned, right, to the scene. It's really powerful stuff here, right? So what I can do is I can take a measurement and yeah, there we are. It is to scale. We're aligning different data sets. So here is a autonomous bus. We've aligned that 3D model inside of the scene. So here we are looking from a bird's eye view. So we can actually review some of the time series data that we've generated for this turbine, wind turbine. So what we've done here is generated some data over the past few days, right? You see here, we can adjust that, scrub through this timeline, and we could look at the sensor data. We can overlay. We can set markers. Incredibly detailed information, and we can access this from anywhere in the world. If this digital twin was 100 gigabytes in size, we can handle it. Because we're using decentralized storage, no matter how much it scales, I really don't have to worry too much about that because it's being distributed across a wide and diverse fabric of nodes. All right, let's move on over to okay, so here is the convention center. You can see it's it runs quite well inside of the browser. Massive amount of information that we're tossing around here, but you know, technology just keeps getting better. So here we go. We're going to go on a flight now again. So I've recolored the points from the previous video that you saw. So this is based on intensity that the laser scanning devices was able to pick up during the scan. So the intensity return on the reality capture device will cause the point to become more green in color, and the less intense returns end up being a darker blue.